So in today's video we are going to be covering Ohm's law kind of as quickly as possible. So if you grab a pen and paper, some way of following along by taking notes, and what we're going to do is outline what Ohm's law is. We're going to go through the fundamentals of Ohm's law, and then we're going to apply Ohm's law in some questions at the end of the video. I'll be adding this PDF as a file that you can download in the description down below so that you can also use this. So what is Ohm's law? Well, Ohm's law is a fundamental law in electronics and definitely going to be the very first law that you ever come into contact with. It states that electrical current is proportional to voltage and inversely proportional to resistance. Now, if we take a look at current here, current is measured in amperes or amps. It, depending on where you are, is depending on which version of this you'll hear. Its SI unit is A, and the SI unit is what you'll see after your value. So 2 amps, 4 amps, 6 amps, etc. And its electrical quantity symbol is I, and its quantity symbol are quantity symbols rather are what you'll see in equations to represent the different quantities. So if we take a look here, we can see that to find our current, what we need is our voltage and our resistance, and we divide the voltage by the resistance, and that will give us our current value. Speaking of voltage, let's move on. So voltage is measured in volts. You might also hear voltage referred to as potential energy, but it is exactly the same thing. Its SI unit is V, and its electrical quantity symbol is also V, so it is nice and simple to remember, and the equation for voltage is V is equal to I times R. That is our current and our resistance. And now that we've mentioned resistance, let's move on to resistance itself. So resistance is slightly different to the others in that its SI unit is represented by a physical symbol or a Greek alphabet symbol. And in this case, the SI unit is the ohm, or the Greek letter for omega. So this is what the ohm looks like, and it comes from the Greek omega. And you'll see it represented in your resistance values, for example 0.5 ohms, 1 ohm, etc. And the EQ symbol, or the quantity symbol, is R. And so if we move over, we can take a look and see that R is equal to V over I, where V is our voltage and I is our current. And it is a really handy way of remembering these equations, and that's by using Ohm's triangle. Now, Ohm's triangle is very similar to another triangle you might have seen in physics, which is your distance, speed, time triangle. And it works exactly the same. We use this center line here as our division line, and we use this line here as our multiplication line. And so when we want to find V, and we can do that by thinking about the triangle in your head and removing V from the top. Once you remove the value that you're trying to find, the quantity that you're trying to find, you're left with the two that you need to do something with. And in this case, we need to multiply I and R, and we know that because they cross the multiplication line here in order to find V. Of course, to find I, all we need to do is divide V by R, and then to find R, all you have to do is divide V by I. So take a note of this triangle. It is incredibly important and a really great way of remembering Ohm's law. Let's move on to some questions then. Let's apply Ohm's law, and all of these questions have been done in the style of exam questions that you might see either in the British GCSE physics exam, or I believe you'll also see this in your normal high school physics exams. Um, so in this first question then, we are given a circuit with a power supply and a resistor. We're told that our power supply has a value of 6 volts and our resistor has a value of 12 ohms. And let's say that the question is asking us to find the current. So feel free to pause the video and try and work it out for yourself, and then unpause the video and we'll work through it together and you'll get your answer. Okay, so we know that I is equal to V over R, which means that our voltage being 6 and our resistance being 12, that all we have to do is divide 6 by 12, which we know is also equal to 1/2 and 0.5. And because it is a current, we need to make sure that we add our EQ onto the end, our quantity symbol, and of course it is amps. So the answer to that question is 0.5 amps. There are 0.5 amperes or amps of current running through our circuit. Now let's move on to this next question then, and this one is a worded question. This is the sort of thing that you'll see more often to the other questions. What we need to do is read through the question and select the values that are important to us. So the question says that a circuit contains a battery of 6 volts and the ammeter shows a current value of 0.3 amps. What is the value of the resistor? So we can see here that we have our battery, and the battery is outputting 6 volts, and so 6 volts is our V. The ammeter, which is a component used to measure the current within a circuit, and we'll go on to that in later videos when we cover circuit symbols and topology, shows a current value of 0.3 amps. And so immediately we know that the question is about to show us the current value, and our current value is 0.3 amps. And so now we have our V, which is 6, and our I, which is 0.3. And so to find R, this is where you should pause the video and try and work through it yourself. R is equal to V over I, which is equal to 6 over 0.3. And you might need to use a calculator for this, but if you don't, then you will know that the answer will be 20 ohms. Again, always remember to put your quantity symbol after your answer, otherwise it will be incorrect. Let's move on to the next question then. Using the same circuit from question 2, if you were to halve the value of the resistor, what value would the ammeter display? Well, if we are using the same circuit from question 2, then what do we know? Well, we know that our voltage is equal to 6. The supply hasn't changed. We know that the resistance in the last question was 20 ohms. So R is equal to 20. And this is for the last circuit. Keep this in mind, it's for the last circuit. The ammeter, which is I, in this particular circuit, we don't know. So these are our values for our last circuit. And now we need them for this one. So V is still equal to 6. However, the question is telling us that we are to half the value of the resistor. And so, of course, 1/2 20 is 10. And now we need to find I. And therefore, we know that I is equal to V over R, which is 6 over 10, which is of course 0.6 amps. So there we go. And I think by now you're probably getting quite a good hang of these equations. They are incredibly simple. On to question 4 then. A circuit is showing a current of 4 amps and contains a single resistor of 8 ohms. What is the value of the voltage applied to the circuit? So, we have our current of 4 amps and we have our resistance of 8 ohms. And we are looking for V. And V is equal to I times R. You might also see it as V is equal to IR or V is equal to I times R, although you won't generally see this one here because in algebra you don't really want to put this multiplication symbol in case you can't distinguish between that and X. But anyway, V is equal to I times R, which is equal to 4 times 8, which we know to be equal to 32, and therefore the voltage supply in our circuit is 32 volts. So looking at this last question then, there isn't really a lot of information to go off in terms of explanation, but we do know that we're looking for the value of V. And again, just like the last question, we're given our amperage and we're given our resistance. And so I is equal to 0.3 and R is equal to 18. And V is missing and we need to find V. And we know that from the last question that V is equal to I times R, which is 0.3 times by 18. And you will likely have to use a calculator for this, so feel free to do that. And you should be getting the answer of 5.4 volts. So I hope that this video has helped to give you a better understanding of Ohm's law and the sorts of questions that you will face during a physics exam. And you'll know that, be able to figure out actually from this video that Ohm's law is quite simple, at least at the very base level. I will make more videos later on that go a little bit further into Ohm's law and lots of different laws in electronics. But let's review for this lesson then. So Ohm's law is, or it states, that electrical current is proportional to voltage and inversely proportional to resistance. Taking a look at current, it is measured in amperes, its SI unit is A, and its electrical quantity symbol is I, and the equation for it is I is equal to V over R, where V is our voltage, and voltage is measured in volts. Its SI and EQ symbol are both V, and its equation is V is equal to I times R. And on the topic of resistance then, resistance is measured in ohms, its SI unit is the ohm, and its EQ symbol is R. And this is the ohm. It comes from the Greek alphabet letter for omega. And the equation for resistance is R is equal to V over I. Now to remember these equations, we can use this really handy triangle called Ohm's triangle. And it is very much the same as your speed, distance, time triangle that you might otherwise use in physics. And to remember best, imagine yourself looking for the quantity and then removing that quantity from the triangle. You're left with two quantities, and all you have to do is use the lines between those two quantities to determine what you do with them. In this case, to find V, we are looking for I times R, because all we have left is our current, our resistance, and the line of multiplication in the middle. To find I, we're left with V over R, and to find R, we're left with V over I. If you enjoyed this video, please leave a like down below. Please, especially as this is the first video, add a comment and tell me what you like and didn't like about the video, and if you really enjoy these and want to see more, please subscribe.